You know that feeling of déjà vu, when it's so intense it feels like you're just replaying a level you've been through before? Or have you ever just looked up at the night sky and had this weird thought, what if all of this is just code? It's a pretty wild idea, but today, we're going to take it seriously.
Look, this isn't just some late-night dorm room conversation anymore. We're talking about serious physicists and philosophers asking this exact same question. What if everything you see, everything you feel, your entire life experience is just part of an unbelievably advanced simulation? Okay, let's really get into this. So let's put a name to it, the simulation doctrine. The basic idea is that our entire universe, from the tiniest subatomic particle to the biggest galaxy cluster, isn't the real fundamental reality. Nope. Instead, it's an artificial one, a construct, a simulation, built by some intelligence far, far beyond our own.
All right, so to see if this whole idea actually has legs, we're going to break it down. We're going to investigate 5 core arguments. Let's call them pillars. We'll look for reality's pixels, the physics of the game, and even the universe's source code. Then we'll get into some really mind-bending stuff about probability before asking the biggest question of all. If this is all true, so what?
So how in the world do you even begin to argue that all of reality is a fake? Well, it's not like there's one single piece of smoking gun evidence. Instead, the whole theory rests on this foundation of 5 interconnected ideas that, when you put them all together, actually start to paint a weirdly compelling picture.
And here they are, the 5 pillars. Think of them like steps in a logical argument we're going to walk through together. First, we'll ask if reality is pixelated. Then, if the laws of physics are just processing limits. After that, we'll explore if math is the universe's source code, if reality is only rendered when we're looking. And finally, we'll hit the big one, the powerful statistical argument that suggests this is all probable.
Okay, our first pillar starts small, like really small. To us, the world seems smooth, right? Continuous. But what if you could zoom in, way, way, way down? And what if, when you got there, you'd find that reality is actually made of tiny, indivisible building blocks, kind of like the pixels on your screen?
So here's the big idea behind Pillar 1. A simulated universe would have to have a minimum resolution, right? It couldn't be infinitely detailed. That would take infinite computing power. It would have to be built from fundamental, indivisible units. And, when we look really closely at our own universe, we find some pretty fascinating clues that this might actually be the case. For starters, quantum mechanics tells us that energy isn't some smooth, continuous flow. It comes in these discrete little packets called quanta. And then there's something called the Planck length, a distance so unbelievably tiny it's theorized to be the smallest possible unit of space, the pixel of our universe, if you will. Both of these ideas point to a universe that's built on digital information, not smooth, analog stuff.
Okay, so if the universe has a resolution, a pixel size, does it also have processing limits? This is where we get to Pillar 2, which suggests we should think about the laws of physics a little differently, not as some mysterious properties of nature, but more like the hard-coded rules of the game engine that's running everything.
I mean, think about it. Any computer simulation, no matter how powerful, has limits. It has a cap on how fast it can process information and render what's happening. This pillar argues that what we call physical constants, these numbers that just seem to govern everything and never change, are actually those very limits.
And the perfect example is right here, the speed of light. Why? Why is there a universal speed limit? Why can't anything go faster? Well, in a simulation, the answer is actually pretty simple. It's the processor speed of the computer running the show. It's the absolute fastest the system can calculate a change from one moment to the next. Nothing in the game can be rendered faster than that. So, we've got pixels, and we've got processing limits. But what's writing the program? Pillar 3 looks at the really strange, almost spooky effectiveness of mathematics in describing our world. I mean, why does this purely abstract language of numbers and symbols just happen to map onto physical reality so perfectly? This slide just lays out the comparison perfectly. In any video game, lines of code dictate absolutely everything. How gravity works, how characters interact, all of it. Well, in our universe, mathematical equations do the exact same job. It's almost as if math is the fundamental source code for reality itself.
Okay, the final 2 pillars are where we move a little bit away from physics and more into the philosophical. And this is where the theory gets really, really weird. And maybe even probable.
So Pillar 4 is what you could call render on demand. To save processing power, video games don't render the entire world all the time, just the parts the player is currently looking at. Well, quantum mechanics has something that sounds eerily similar. Particles seem to exist in this fuzzy cloud of probabilities until we observe them, and our observation forces them to snap into a definite state. It's wild. Is reality only bothering to render itself when someone's looking? And then you have Pillar 5, pure, simple statistics. The logic goes like this. If any civilization, anywhere, ever, gets advanced enough to create realistic simulations of their ancestors, they're not going to make just one. They're going to make thousands, maybe billions of them. And if that happens, simple odds say it is overwhelmingly more likely that we are living inside one of those billions of simulations than in the one, single, original base reality.
Okay, so let's just pause for a second. After walking through those 5 pillars, we have to ask the big question. What if it's true? If our reality is just a construct, what on earth does that mean for us? For science? For the meaning of life itself? This quote from the physicist James Jeans just nails it. It perfectly captures the change in perspective. If the simulation doctrine has any truth to it, then our reality is less like this great clockwork machine made of physical stuff and a lot more like a great thought, a computational system built on pure information. And that is the ultimate takeaway here. Whether we are literally living inside some alien's computer or not, all these pillars point toward the same mind-blowing conclusion that reality, at its most fundamental level, seems to be made of information. It runs on rules, it can be described by code. It really is less like a great machine and more like a massive, running program.
And that leaves us with one last, kind of personal and maybe unsettling question to think about. If this whole life is an incredibly advanced video game, what part are you playing? Are you a conscious player sitting at the controls? Or are you a non-player character, an NPC, just running on your pre-written script? Something to think about.